libraries. It's not too long today, just kind of an overview and intro into what design libraries are, where they are, and how you can make some smart components and smart features that go into your design library. Before I get started, I do want to launch a poll here. So hopefully you can see a yes or no question. And all I'm wondering is, have you used design libraries before? So in your GoToMeeting window, you can hit yes or no there. And it'll kind of give us a better understanding of where people stand for this. Perfect. Thank you for voting. So based on that, we're at about 57. 57 said no, they haven't used design libraries. 27 have said yes, they do. Perfect. All right. So now, on to what we're going to talk about today. So our agenda is what's a design library do? And where does it live? So where are these parts coming from? Where are these features coming from? And how can we add and use them? Then we'll go into what comes with SolidWorks. So what's your basic SolidWorks package as far as the design library goes? So the folders that come with it. And I'll walk through the folders just to show you some examples of what's going on inside of there. Then I'm going to go into some smart components, how to use them, how to create them, as well as smart features, and how to create both a part with its component that's going to use the features from it. And that sounded very confusing, but I'll explain it when we get to that part. And finally, I'll go over some of the extras that come in with this design library. So the toolbox for our professional and premium users, any downloadable content, as well as what SolidWorks gives us for free. All right, so starting here, we can jump in. So what is a design library? It's those 3 books that have lived in SolidWorks for quite some time. So for the 60% of people on the webinar today that haven't used them, that's what those books mean. It's an access point into your design libraries. It also gives you the ability to customize some folders. So inside our design library, we have a folder structure which can be built upon. You can create your own design libraries if you're a networked user and you want to manage your own parts in a network or on your computer. So you can have a shared design library as well as a personalized design library. This ends up being a huge time saver if you're using any repetitive parts. I'm sure Toolbox customers understand that being able to drag and drop hardware is a huge time saver, that you're not modeling it up. It's always going to be consistent. So it's going to reshape to what you need it to be. It's such a big time saver, in fact, that this is the we do about a design library webinar once a year, pretty much, for the past couple of years now, just to let you guys be aware that information's out there, that they're very useful, and that they are going to help you save time in the long run as you start to utilize them. So for some more information, the one that was done last year lives out on YouTube. You can ask me for the link, or you can just search our CAD Dimensions YouTube page for a design library webinar. This one covered creating folders, saving parts and assemblies, and saving features and blocks, as well as some sheet metal forming tools. So what I'd like to do today is try to build on top of that. So go more into the folders that come with the software, as well as some of those smart features and components. So I don't want to repeat, but I do want to touch base on some of the high-level items. All right, where does our design library live? When you install SolidWorks, it goes right into your default location, which is under Program Data in your C drive, which is a hidden folder, so you might have to type that one out, /SolidWorks, and then whatever year you're using. So I'm using 2015 today. Inside of there, you'll have a folder called Design Library with more folders underneath for all your setup. Then we have another option to get there is from our Tools Options, System Option File Locations, which you can see here. And this gives you the opportunity to add some other libraries to it. So we can do it from this interface. I'm going to show you an easier way to add design libraries to our software, or to SOLIDWORKS. Last one is add libraries anywhere. So this is a real nice feature that you can create folders on the fly and add file locations on the fly by dragging and dropping. So as you want to develop a design library, you can organize it to fit your needs, and you can add and delete at will pretty much. All right. So with that said, I do want to jump into SOLIDWORKS here just to show you interface-wise where this stuff lives. So like I said, it's going to live on the right side menu here. It's called Design Library. And these are the add-ins that I'll talk about in a bit. But as far as the design library goes, we get these, it ends up being 10 folders, 8 folders. We get these 8 folders by default that come with SOLIDWORKS. And I'll go through each of these individually. But what you can also do, like I have here, is you can add your own library. And the way we do that is just by doing add file location, depending where you want it. So if I create a new folder, I can call this a Lunch and Learn library. Select it, say OK. And just like that, SOLIDWORKS is going to create this new library, which we can add folders to. So I'm quickly organizing reusable content that I want inside of SOLIDWORKS. All right. Other locations where we could have found that, again, is System Options, File Locations, and then your drop-down here for your design libraries. And you'll see that the one I just created goes there, as well as the one that I created earlier, and our standard design library that gets installed with SOLIDWORKS. All right. Jump back here. So our library features, we're going to go through each of these folders, and I'm going to show a quick example of what each folder has inside of it and what that can do. So starting with parts, all I'm going to do is grab my part folder here, and as I expand it, we can see some of the options that are inside of it, and I'm going to grab a knob here. So quickly, without going to File, New, or to do any modeling, all I have to do is use my design library, double-click, and I have a part with all the features that I want inside of it already created. So real quick way to get geometry that you need, even if it's a block or a base part, it doesn't have to have all these features. If you just quickly want to create something, you can form it inside your design library. Conversely, if you created something that you think you're going to use a bunch, I'm going to show you how you can drag and drop it right back in there. So I'm going to create a new part. This one is going to be a block. So maybe I want to do a quick cut on this. So just put a hole right through it. Say OK. When I save this, I want to save it just to my desktop for the time being. And we'll call this cut block. So now that I have these two features, I believe that I'm going to use this over and over again. If I want to use it inside my design library, all I have to do is left-click on my part property up here and drag it into my library. My arrow will turn into a plus sign. I can go ahead and drop it. And what that does is triggers an Add to Library command over here. So now I can rename it to a file type that I'll remember. I can choose which library I want to put it in. I tell it that it's a part, and this is a block with hole as a description. I go ahead and hit OK, and just like that, it's going to drop it in there. So now at any point, if I want to reuse this part, it's a double click, and I'm currently editing that. All right, I hope that made sense. Next on my list, features. So what can we do with this design library now? So I have this part. I'm going to go into my feature tab. I get a couple different ones here. I get inch ones, metric. Actually, I'm going to go back and use that part that I just created to test some of the features. So I'm going to stay in inches. Ooh, we get a lot of sheet metal ones. And what you're noticing here is these are a lot of cuts. So a feature is going to be a single feature type, whether it's patterns. This one's a keyway. So it's going to create a cut feature associated with another part. So if I'm looking, let's see what I want to do here. We'll do a slot just to keep it simple. So if I want to bring in a slot into this design, all I'm going to do is drag and drop, and I'll get a preview, and I'll get a message on the left side just to place it somewhere on the model. So I get a preview of what feature I'm bringing into my model. And once I let go of my mouse, I'll get prompted on a configuration for that. So I can choose my size, and a new pop-up is going to ask me for references of this feature. So as I pick and choose the size that I want, I can go a little bit bigger here. All right. So I'll grab this one. It's going to ask me for 2 references to help identify where to locate this feature. So you'll see that it's highlighted blue here, looking for a left edge, and I can click on my model. My question mark will turn to a green check. Now it's looking for the top edge. And once those 2 are placed, my feature will actually be created. So it's an instant cutout here. If at any point I know I need this feature, but it's not to the right dimensions or to the right location, we can override our dimensions here. So if I really need this to be 3 inches away and maybe 2 inches down, oh, too far, 1.5 inches down, we can override that location as far as a drag and drop goes. We can also override the configuration that we selected. So if I need this to be slightly wider and much longer, I have complete control of that smart feature, and it's all coming out of this library straight slot. So I can hit OK there. And what that creates is a library feature with a slot cut. So it's a quick way to edit a part using some predefined features. Just looking at a couple others here. You can use the hole pattern. Drop them down. Placement plane is going to go on the front face of this. Pick the pattern we want. Select an edge that we want. And we can quickly create a pattern around that edge. So again, just an ease of use tool to create features. All right. You can also save out assemblies and bring in assemblies. I'm good with this one. I'm going to go into my assembly folder. Drag this down so you can see what the folders are. So inside our assemblies, we have a couple ones here. I'm going to grab a gear model that I created earlier. The example that comes with the software is this mold action assembly. So just so you can see that it's about a 50-part assembly here that gets saved out into our design library and can be accessed at any point. So this one, I'm going to go up a folder, grab my gear model, and drag and drop them in. So real simple assembly here. 2 parts. I got this has a concentric mate here, and I'm going to give it a little bit of spin just so I can rotate it. If I turn off my axes, we can't really see if I'm spinning it or not. So again, a good time to use a smart feature would be here, where I can quickly come in. I'll grab that slot again. The thing to know now is I can't use a slot on the assembly because I need to be editing a part. So if I want to come in, I can say edit part. Now that I'm in edit mode, I can grab this. I'll drop them down. I'll hit OK. I choose configuration first. We'll give it a couple edges here, and I can quickly create that slot and get out of my edit. So now I can see when this is spinning. So that looks okay. The next one on my list here, so that's just showing that assemblies can be saved in and out of our design library. Smart components, actually I'm going to jump down to motion while I'm inside this assembly. So from here, I don't know if anyone's used a motion study before, like we have here, so I'm just going to delete this one and create a new motion study. From our design library, we do have a motion folder, and what this gives us access to is a couple springs, a damper, and a motor. So I'm going to use this rotary motor for this example. And again, it's a drag and drop onto our model. So for this, I'm going to use the edge here to define the rotation. Actually, I'm going to flip it around. And the other thing for our component is just what's stationary. For this one, it's going to be the stick. I want it to go some constant speed, and that looks good. So I'll hit OK. And now I can run a quick animation just to show the rotation of this part. And all that's being done based on this motor, which can be set up all from our motion study, but it's a lot easier just to drag and drop and bring that in to give ourselves some animation. All right, so we got that one off the list. So now into smart components. So I'm going to bring that in, and I'm going to talk about smart components a little bit more in a bit. Let me just shrink this down. I'm going to go back into this plate here. So this is a part right now. I want to save this, or I want to make an assembly from this part. So my cut block from the Lunch and Learn is now inside an assembly. And I'm going to come into my smart components. And for this one, I'm going to grab a hydraulic clamp. So a pretty big part here. I should have made my plate a little bit bigger. But you'll notice that as I'm hovering over my plate, it's snapping to it. So if I'm off in space, it doesn't really know where it's going. As soon as I hover over my plate, it knows that it has a smart mate, a face-to-face coincident mate. So as soon as I bring that in, it's going to prompt me for configuration. And I'll hit OK. I'll hit exit to get out of there. So what's nice about a smart component is that it has this known mate reference to it. What's also nice is that it has a smart feature tied to it. So if I left-click on my hydraulic clamp here, and I click on the star, what's going to happen is a smart cut is going to come out with this. So as you can see, we have a couple rings going here. And as I move this, I can update where that cut goes. So it'll follow me depending on the placement of this smart component. And I'm going to show you how we actually go through and make that smart feature assigned to our smart component. But again, real useful that I don't have to worry about how this all gets mated into a part. All I care is that it sits on the face of the plate, and then all the cuts are going to come with it. And once I design that once, I can reuse it over and over again. So that's our smart component. Forming tools. So forming tools are used inside of sheet metal. So I'm going to create a new part here as sheet metal. So I go into my sheet metal tab. I'll quickly design up a U here. Get out of here, and I'll just extrude it some distance here. All right, so now I'm working in sheet metal. I have my sheet metal folder, face flange. I'm going to close down my parts and come into forming tools. So what forming tools give us is the ability to create different parts, or different features inside our sheet metal tool. As you look closely here, you can see we have yellow edges and red edges. A yellow means it's just going to, I should have made this part a bit bigger. Let's see if that agrees with us. All right, let me make my base a bit bigger here. All right, now we got some room to play. Let me delete that feature out. All right, and we will expand this one to now we got a surface to play on. So in my sheet metal, as I drag and drop this circular emboss and hit OK, you notice that it's putting a dent right into my sheet metal. It's not cutting through it, but it is pushing it enough. Conversely, if I wanted to do another emboss with a cut through it, this one's quite a bit smaller, and I hit OK, when it's got a red face on it, that means it's going to finish through the cut. So one's a through all, one is just a push emboss. So it's still working on sketches. It's still like any other smart feature, but now we're dealing with sheet metal properties. Where this becomes pretty cool is for Lance here. So as I bring this one in, hit OK. What we can now get is some extra flanges. So a pretty complicated feature to do inside of sheet metal, we can do with the drag and drop now, where I have a cut extrude that's grabbing that material and actually giving it a bend. So we can do a couple of these. This one's going to go up on the other side now. So pretty cool features. And the last year's Lunch and Learn talked into how to create these sheet metal features. So I recommend you giving a watch of that video if you have more questions on sheet metal. All right, we did motion. So annotations is next. So what I can do is grab this part here and make a drawing. Save it first. Part 8, great name for it. So I've now created a drawing based on this. I'm going to take my bottom view and bring them in. So I have my details here, and right now I'm in my view palette. If I come up to my design library, I can click on annotations. And what this now gives me the ability to do is quickly define some marks that I might be using consistently on a drawing and drag and drop them in. So I mean, this one's going to be for a P&ID. And it's just a block, but if you're consistently using blocks, instead of doing insert annotations, block, going out, finding where your block is, browsing for it, grabbing it, a lot easier to have them saved inside your interface, and then all you're doing is dragging and dropping a common reference that you're using. So all these features are going to, or all these annotations are going to live right there. And again, if you need to organize it, we can always create folders around this structure. So this is for weld. I can come into here, grab the items that I need, and just drag and drop them into my weld folder to further organize what I'm trying to show as a weldment. Now they're all going to live in here. All right. The last one's routing. Which I talked about last month in our webinar, but I do want to just show you what's inside that folder without doing a full route here. So what we get inside of routing are any fittings as far as valves go. I'm usually working out of the electrical routing, where we have different connector types and our clips, which come in handy if we're going to route through a clip. I open this up. We'll see that we get a couple mate references, like you're used to for a smart mate. So that's where our clip's going to snap. We also get, this one doesn't. Oh yeah, here it is. We get an axis of rotation, so we want to rotate this clip around, as well as a clip axis, and that's where a wire or cables are going to run through this clip. So again, all this stuff is living inside our design library for easy use. All right. I forgot to mention this at the beginning. Inside your go-to webinar, there is a questions area. So if anyone has questions, feel free to ask, and I'll try to get to them live, or I'll get to them at the end of the presentation. All right. Next, we're going to go through some smart components. So we talked about these a little, but I want to show you the background of where this information is coming from. So again, it's still using these library components, but it's using configurations and auto-size features internal to that to make them a bit quicker. So I'm done with this drawing. So all my example parts now. All right, so this is just a shaft with 3 different diameters coming on it. I'm going to go into my design library, and I have this bearing that I want to apply to each of these. So again, design library, so it's going to be a drag and a drop. But you'll notice on this one, as I go from level to level, my bearing's actually resizing itself and figuring out which configuration it needs to use. So let me get a better angle here. So as I come down to here, I'm on my smallest configuration. As I jump up a configuration. And for my final one, I'm going to jump up to a 3rd configuration. So quick way to redesign parts based on the geometry that it's snapping to. So what I do want to do is open this part up just to show you the history of how it's capable of doing that. So inside this part, I'll go to my feature tree, and it is a part, despite the it looking like an assembly. It is just a part. But we have 2 folders that you may not be used to. One of them is the smart feature, and one is the mate reference. So if I look at the mate reference first, you'll notice that it's highlighting the inside of this. So that means when it finds another cylinder, it's going to snap to that with a concentric mate. The other one here is the smart feature. And inside our smart feature, we have an extrude, and we have some references. So I'm going to actually edit this entire part here just to show you what's going on. So when we do edit the smart component definition, we launch a new window, and it's got a TA, which stands for Training Assembly. And what the trainer does is gives us some references that we can apply to our part. We also get this edit definition window that hovers right over our minimize and escape, which is fun. So from here, I'm going to edit the definition. When I'm inside of here, we'll notice, because this one's already done, and I'll walk us through the step of how we're doing this, we can see the component that we want to make intelligent, our smart component, is going to be our bearing. We also get to see our features that we want associated with that. And for this one, it's going to be this extruded block that comes with our feature. Where the auto size comes into play, so how it knows what to snap to depending on the diameter, is the auto size is related to this space. So whatever the diameter of this is, or whatever the diameter of the part that you're mating to, this should resize to that. So that's all this clip is there, all this tick mark is saying, is resize to its mate. Where the smarts really come in is for this configurator table. So at the very bottom of our smart component, we have a configurator table. And what this is telling us is if the diameter of that shaft that we're putting this on is between 20 and 25, then we want to use our 16 or MTD 16 configuration. And that's going to have the diameter of our bearing to match a 20 to 25. And each step up, it's resizing based on the diameter of that shaft. So we wanted to create a smart component that auto-sizes. It's going to be driven from this configurator table here. All right. And again, when we're done with this, we can leave. We don't want to save our training file, so we can leave this. Save all. And when we're back into our part, we can see that it's a smart feature. All it's going to be is a drag and drop. Now I have a lunch and learn one. Hit OK, and we'll add it right to our library here. Pretty neat. All right. Creating smart features is So that last example didn't have a smart feature tied to it. All it was doing was finding a mate reference and then snapping to it and resizing. What we can also get out of this, like I was showing you with the smart component, that red valve, is we can get a feature to come along with our component. And I'm going to do this one from scratch just to show you the steps that involve to create this smart cut. So I'm done with this. And I'm done with this. Got a lot of files open. All right, so I'm going to start new. And my first part is going to be, actually I'll just grab this block. So new block, just like that. And I'll go ahead and save it into my webinar folder. So this is called block. Inside this block, actually I'll create my screw first. So I have this block, and now I want to create a new part, and I'm going to create a screw that's going to fit into that block. So I'll go here. I'll draw the profile of my screw. That looks good. I'll throw some dimensions on it. That works. Okay. I forgot when to get fully defined. Perfect. So now I can come in. I'll revolve this to create my part. Say OK. Cool. So now I have this part. I'm going to save them. So I have a plate and I have a screw. And I want to create an assembly on these two. So File, make assembly from this part. I have my block and I have my screw. I want to bring them both in. There's the block, and there's my screw. All right. So I want to be able to have a smart component that I can put into my design library here. As you can see, I've tried this a couple times before. I want to be able to bring this in and create a hole that goes along with this screw. So if I'm going onto a flat or on a solid surface, I want to bring a screw in, but I want to create a hole that goes into that solid surface automatically. So what I'm going to do is actually create a hole inside my block here. So I'm going to edit my part. I'm going to save my assembly first. So we'll call this a smart. All right, and all I'm going to do is put a whole extruded cut into this. Features, extrude cut. And I want it to go through all. All right, so with that done, I can come back into my assembly. And now I'm going to do a concentric mate here. I'll mate them up there, and I'll mate them here. All right, so now my screw is inside the hole. The hole doesn't really fit, but that's okay, because this is going to end up being my trainer block, so it's just for show, really. So I'm happy there. So from my assembly, I want to create a smart component. So we get a couple different smart features. I can do a smart reference, which I'll do in a second, but I want to do this smart component. And it's going to launch this dialog box on the left side asking, what component do I want? So I want my screw to be the smart component. I don't have any associated hardware with this one. So if I had associated parts that I wanted to bring in every time, if I had an assembly of components, this is where I would select that. So any hardware tied to it. And the feature that I want to capture is this extruded cut extrude. So now I have a link to my screw and to this cut extrude. And again, if I wanted to auto size as far as mate goes, I could drive my configurator table. But for this example, I just want that cut to come with it. So I can say OK. It'll think a bit. And with that, my screw becomes a smart component, and I get a little star tag to my symbol. And I want to open this part up. You can see I have a smart feature, and that feature is the cut extrude. Before I go ahead and save this into my design library, I do want to make that smart mate tag to it. So using my command box up here, I want a mate reference. This one's nice too because I keep calling it Smart Mate. If I type in Smart, mate reference still comes up with it. So my mate reference is I want to be able to lay flat on the plane that I'm placing it. So all I have to do is select that face, and I want this one to be anti-aligned, I'm pretty sure. If not, I can always come back and change it. And my mate is going to be coincident. So I say OK. And now I have a mate reference folder that gets generated with my default mate. Now I'm happy with this screw. I'm going to save it. And now I'm going to drag and drop into my design library. I'll give it a new name. So this is now our Lunch and Learn screw. There we go. Hit OK. Now I have an L&L screw here. So I'm happy with that. I'm going to close out of these. And now I'm coming back into my block. So if I suppress this feature, oh, so this is not going to work. So my block is a part. I want to be inside an assembly. I'm actually going to make an assembly from this part. Bring my block in. There we go. So now I just have this solid block. And I want to bring in my screw to this block. And you'll see that my Smart Mate is now working. If I go off in space, it'll be sideways. As I bring it in, it snaps right to it. I'll go ahead and accept that. And I only want one screw. So right now, I don't get that cutout that I wanted. It's not until I click here, and I click on the star, which is Insert Smart Feature. It's going to prompt me to pick a face that I want associated with it. That's going to be the top face for this one. I get a green check. I can hit OK. And now I get that. My cut is a little small here because it's stealing it from my trainer file. So if I made that the correct diameter, it would be associated with it, and it would actually, it's going to follow as I drag this placement. So because that is a little bit small, I can come back into this. I can edit. Oops, I don't want to edit that. I want to actually open up my Lunch and Learn screw. Edit here, and now the block is what I want to be able to edit here. So what is my diameter here? 2. So I want to change my sketch and throw a diameter of 2 on there, just so it makes sense when I'm inserting it. I can leave my component. Again, this blocks it. Once I do a save all. Good there. Good there. So now, if I bring that back in, so let me delete this part. Hopefully, if I did all my saving right, I should have the correct size hole with my Smart feature. Select my face. There we go. So now I have that 2 diameter hole. So that's the linkage between the trainer and your Smart component, is that it needs to know the features that are associated with this just in a dummy part or a dummy plate. And now if I wanted to grab a different assembly, so if I go back into my design library, grab a larger assembly, I can still use my Smart component. So let me grab my library. So I can still bring in my screws to this new assembly, turn on the Smart feature, select my face, and now I'm adding cuts to this component. So a nice way to have a quick access point to parts and features inside assemblies. All right, so now some of the extras. Toolbox, like I said earlier, comes with Professional and Premium of SolidWorks. And what that is, if you haven't used it, it's an add-in to SolidWorks. So I'm just going to turn that on. And what the toolbox does is recognize hole features, so any hole made with a hole wizard. And it will give you access to a bunch of hardware, so default hardware. Without knowing how this mold was made, I'm kind of taking a guess here. Let's see if I can get it to cooperate. There we go. So what this will give us access to is a whole bunch of hardware created on the fly with some smart mates tied to it. So as I want to pick and choose the size of the bolt I want to use. So now I can quickly place my hardware inside my model as I go around based on the configuration that I chose earlier. And all this is looking for is a peg and hole smart mate. So Toolbox is very powerful if you're trying to show all your finished hardware inside an assembly. The other ones are downloadable content. Let me shrink down Toolbox. So 3D Content Central is a SolidWorks website where you can have access to supplier content. So if I'm going to look for all suppliers, it'll launch my internet. And it does require you to log in, but it is free with SolidWorks. Actually, I think it's free without SolidWorks as well. But it's a Dassault website, and from here we can look for manufacturers on this database. And what they provide us, if I click Max Pro here, what they provide us is SolidWorks models that we can download directly. So this one has configurations. As I click it, it does have a preview window that I don't have the plugin for. But it does give us access to that 3D model that we need. So now I have a SolidWorks part and assembly file, the version that I need it, and I can even go as far as picking the size that I want for it. I can download that, and what it will do is populate in my design library. So this is super helpful if you don't want to recreate the wheel. If you know a part exists out there, if you know it's a catalog item, check 3D Content Central first, and download it, and just bring it into SolidWorks, and then you have access to it. Last one is SolidWorks content. So I know I believe Kevin did a blog post on this a couple months back. But what we do have with SolidWorks is some of this free content. And what it gives us is a whole bunch of library data concerning routing, weldments, circuit works for any circuit work parts, as well as some high-level blocks. And I know the weldment one gives us a full library. As I double-click here, of weldment profiles. So actually, you get a control-click. And what it will do is download that content for us. So all weldment profiles that are referenced as an ANSI-inch metric, or standard, not metric, as an ANSI as standard, is on inside your download of SolidWorks, and this is how you get access to it. So any of those weldment tables that you're used to seeing, this is where that information comes from. And there's a whole bunch of standards there that are downloaded for free from the SolidWorks content in your design library. So everybody likes some free stuff, right? Now that I look into my content, it's under test. So now my weldment profiles have been downloaded to there, but because it's not a library part, so now that just means I have access to it. So as I open this folder, it comes in as a zip, and now all these profiles are downloaded to this directory. All right. Oh. That's all I really wanted to talk about design libraries today. I wanted to make sure you guys were aware that they're there and that they are very helpful if you're using them. Some upcoming events that CAD Dimensions has, as always, they're on our website. There's a simulation lunch event in our Rochester office first week of March, and then we have a lunch and learn with Kevin on March 11th, talking about data cards in SolidWorks EPDM. In case you missed anything or would like to re-watch this webinar today, you can go to info.caddimensions.com/connect and find our YouTube channel, follow us on Twitter or Facebook, and as always, check out the CAD Dimensions blog. We're posting very relevant content out there about twice a week. And if you guys have any ideas for a blog post or a webinar or a lunch and learn like this, anything that's tripping you up inside the software that you think would be useful for other people to see or to know, please just shoot us an email. Let us know. We're happy to get some user content into these sessions. So I appreciate your time today. I'll stick around for a couple minutes after here. If you have any questions, just throw them into the questions window in your GoToMeeting. Appreciate it, guys. Have a good day.